All right, the last of our three trigonometric functions is what they're called. Tangent. So if you've done it right with sine and cosine, tangent should be no different. We start off by reminding ourselves that we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the one we're going to focus on is tangent. Tangent is the opposite over adjacent. It's the toa at the end of SOHCAHTOA. So, the tangent of an angle, say this angle, is equal to the opposite side over the adjacent. The hypotenuse is not involved, so it's helpful to kind of notice where the hypotenuse is. So this is the opposite for that angle, and this is the adjacent. But tangent's always going to be that opposite side over the adjacent side. And so applying that here, first thing we do is we figure out what we have, opposite, adjacent, hypotenuse. So that means that the tangent of 28 degrees is equal to opposite, we'll call that x, because I don't know it, over the adjacent, which is 44. And as we've seen before, we multiply both sides by the 44. So the tangent of 28 times 44 is going to give us our answer. So if you break out your calculator, let me get out this one this time around. Let me go with the other one. Be consistent. So, get our calculator out. We're going to do the tangent of 28, so we clear everything out. We type in 28, that's the angle. Take the tangent, it's right there. Sorry, it's right there. Then, times the 44. And I get 23.4. So that means this opposite side is 23.4. Alright? And all I really want you to do, so for now, that's all I want you to find is the opposite side, or the adjacent, whichever one's missing. You could go back and find the hypotenuse using Pythagorean theorem, but for now, we're good. Let's just do finding either the adjacent or the opposite, whichever one we're missing. So let's try setting up this next one. So here, starting with this angle, this would be the opposite side. Doesn't look like I have it, so we'll call it x. This is definitely the hypotenuse because it's the longest, which means this is the adjacent. That means that the tangent of 75 degrees is equal to the opposite, I don't know that, over the adjacent, 7.5. And just like the previous one, I'm going to multiply both sides by the 7.5 so that I have tangent of 75 times 7.5 will give me this opposite side that I'm looking for. So I type in on my calculator, I type in the angle first, 75, I hit tangent, and then times 7.5. 27.99, we'll call that 28. So this opposite side is 28. Alright, so only difference with the next couple is going to be that if you look at it, this is the opposite, so they give us the opposite. We don't care about the hypotenuse right now. This is the adjacent, the one we're missing. So when I set this up, I have the tangent of 35 degrees equals the opposite, which is 10, over the adjacent. We'll call that the x, the missing one here. Now, a few times we've been through this, so hopefully you remember now that this and this can just switch places. I can write the x there, and I can write tangent of 35 down there, which I can do in a calculator. If I clear out, I do 10 divided by, and then I do the angle first, 35, hit tangent, and that's not my answer. I have to hit equals. There's my answer. So that missing side is 14.3, we'll say. So this is 14.3. Once again, if you wanted the hypotenuse, probably the Pythagorean theorem is a good way to go. All right, let's try this last one. You should try it on your own and then come back and look at the video and see if you did it right. So I'm going to have opposite, hypotenuse, and the adjacent is what I'm looking for. So I'm going to say tangent of 69 is equal to 2173 over the adjacent, the unknown. I'm going to switch these two. X equals 2173 divided by the tangent of 69 degrees. I'll do that on my calculator. So 2173 divided by 69 tangent equals 834.1. So 834.1 is that adjacent side. Okay.